Well, Math 96. Today's Monday, or maybe you're viewing this on Tuesday. It's October 5th today. So we're going to do section 2.2 on your note-taking guide, page 17. So I just wanted to make sure you knew something. So this is just a little image of page 17, and you can always tell which section we're on. It's in, if you just look to the left, it's on the top left of the page that you have there. Okay. So the essential question, you should be writing that up at the top of page 17. What does f of x, that's how you say that, f of x. So this you say as f of x. What does that notation represent and how is it used? So f of x. And at the end of this lesson, you should be able to say that you can use function notation to represent the y value in your functions. You do have homework tonight. It's on page 90, number 35 to 40. And that slide does appear at the end of this recording, so just listen all the way through for the homework. Okay, so if you can take a minute to hit pause on your video and copy that down. The domain is the x values in the coordinates x comma y. Range is the y values in the coordinates x comma y. And like I said before, f of x is called function notation, and it's just another name for the y in y equals mx plus b. So don't panic about f of x, okay? It's just another name for the y. Okay, so here's example 1. So here's just a bunch of points, and they want us to list out what the domain is. So that's just all the x values. So we would just list -4, 3, 0, and -7. That's all you have to do because you have to register that the domain is the x values. And then the next one, they just want you to list out the range. So that would be the y values. So that would be 2, -6, 9, and 12. Because all the range represent is the y values. That's it. Nice and easy. Okay, so we need to get used to the interval notation for domain and range. So interval notation, you either have a closed or open interval, and we did go over this in Algebra 2. Closed will use brackets. Open will use parentheses when we write our answers. And then a closed interval has a closed dot. An open interval has an open circle or arrows on the end. That represents infinity. If you have arrows, then you have infinity. You can have either positive infinity going this way or negative infinity going to the left on the graph. You can have positive infinity going upwards or negative infinity going downwards. Okay, so domain, remember, is the x values. So you are going to be looking to talk about these numbers. And what you want to do is you want to just go ahead and start from the left. This is a closed dot. At what x value is that closed dot at? So a closed dot, we're on domain, because remember, domain is x. Closed dot is going to be a bracket. And that closed dot starts at -1. And put a comma. And then you're looking along the yellow line to where it ends. So you can see right down here, they're trying to show you the domain. And it ends at an open dot, so we need a parenthesis. And it ends at the value of 4. So that would be the domain. You can hit pause if you need to for a minute. Okay. Then we're going to look at the range, which is the y value numbers. Oops. Okay, so your range is your y value. So you want to look at how low something is. So this goes down to -5. That's also a closed dot, so it's a bracket. And then how high does something go? All the way up to here. And if you look across, it's at 4. And that's another closed dot. Doesn't go any higher than that because there's no arrow. Okay, so how wide is something is the domain. How high and low, oops, I said the wrong word there, sorry. How high or low does something go is your range. Okay, so you're going to find the domain and range for each function and write it in interval notation. So along the x-axis is your domain. For your y, it's along for your range. Okay, so the domain is easy to see. It's closed dots on each end, and it travels from -3 to +3. Always work from the left to the right. Don't forget that this is 0. For your range, your graph goes, the lowest is 0 up to 2. Okay, on this one, so we're going to do the x-axis first. Some of this posed some problems in Algebra 2. Just remember that this graph would go forever and keep getting wider. So what kind of x values would it have? Would those still keep going over and over? And it has arrows, so that's going to involve infinity. So your domain and your range for this one. So your x values will keep going all the way this way because the graph keeps getting wider. So with infinity, we always use parentheses. This is going to keep going this way, which is negative infinity. And these arrows will keep your red line at the top going forever, so to positive infinity. When you use infinity, use parentheses. Okay, so if you were to extend this y-axis, this is going to, whoops, this is going to negative infinity. And this graph is just going to keep going down. But it doesn't keep going up forever. It only goes up to 3. So the range for this one is going to go keep all the way from the lowest number, negative infinity. And all infinities have parentheses, but it only tops out at 3. And it doesn't go any higher, and that's a closed dot at 3. Okay, example 4 we will be doing together live on a sync day, so we're going to skip that. Same with example 5. Okay, this is the vertical line test. If a vertical line crosses a graph more than once, then the graph is not a function. So your answers here, and this is how your homework is, you're going to state whether you have a function or not a function. So your answer should be either the word function or the 3 words, not a function. So right here, what they're trying to do is draw a vertical line through this function, and you can see, and you can draw multiple vertical lines, sometimes you have to. So if we were just to draw vertical lines through, you can see, and we might as well just do this on all of them. Just draw vertical lines. That's what the vertical line test is. You just randomly draw through the function with a vertical line. That's all that means. And what happens is you look, well, over here, my green line only hit once. It only hit the graph once, but right here, it's hitting the graph 3 times. Again, here it's hitting 3 times, here it's once. If it hits more than once, then this is not a function. That's all the vertical line test is. This green line only hit the graph in one spot, so this is a function. This one only hits in one spot, so this is also a function. This one hits multiple times, twice, right? Many times it hits twice, so this is not a function. Okay, so this is your homework for tonight, page 90, number 35 to 40. Please copy the graphs just on regular paper and apply the vertical line test so that you can tell me your answers will be function or not a function like we just did. You can hit pause here so that you don't even have to open up your textbook. You can copy these down on a piece of paper. Thanks, you guys.